Okay, so do you have any question for the class? I will read some of the assignment already, right? So do you have any question with the grade, or I also put up some of the comments in the work. So if you have any question, let me know. Any question? I just want to review about some of the homework here. I don't know for the debug number 1 and the debug number 2. I even corrected on the class already, right? But I don't know, for some reason some of you still make the mistake here. I don't know. And the most common mistake you guys have is that is consistent variable name. That is the most common here. And I already clarified on the class that in any case, any program, you have to be consistent with variable name here. But for one reason, I don't know, many of you make the same mistake again. And even that, I already correct the number 1 and number 2 on the class here. Okay, so here's my suggestion. Check again with your grade and check again with my comments in the work. And if you have any question, let me know. Any question? No. Okay. And the other one I want to mention here is that I don't know for what reason that some of you when you submit the Raptor file, I'm not able to open it. I'm not able to open it here. So here's the thing. I had this one here. I don't know for this one here. When I open it, I had the error here. Invalid file is not a flowchart about recommend selecting yes. But when I click yes, I'm not able to see anything. So I see you, Jack Barrow. Are you online here, right? Hello. Yes. So can you let me give you the the cohort here so we can. Okay. So can you open your program? Can you share the screen to see what happened with your Raptor here? I don't know what happened with this one. I'm not able to find I'm not able to open the Raptor file. Can you share the screen and run the program? So I want to see what happened with the program. Okay, so first question is that your computer, it's a Mac computer, right? Or Windows computer? Hello? Yes, that's my reason here, because you run it on the Mac computer. I don't know, it must be question for me. Okay, can you click run on this program? Can you run it? Oh, on Windows. So why I'm not able? Oh, the question here. Now the thing here, which version of the Raptor you downloaded? Look at question for me. Which version of Raptor you run it? Yeah. So from where do we look? Where? Yeah. Let me see. This version look very weird. Oh, you download version, this version, right? Oh, that's the thing. Okay, I got it. So normally I run it on portable version. I mean, it's not supported. Okay, anyway, I can update it here on the new version. Yeah, you can work on the portable version because that's the thing. I strongly recommend you to work with this one. This one, the version. Okay. Let me try it again. Uh,
So you would like for us to use the flash drive to download?
Say again.
You want us to use a flash drive to download this?
No, I think I'm figuring out where I saw this. Where.
Mine says blocked by administrator.
Sorry, say again.
Mine says blocked by administrator.
See where that is. Oh, it's not. I don't know why I'm not able to install this one. That's why. Okay, it should be better that you do it again with the portable version here. I don't know why I'm not able to install this version. Okay, so specifically for the assignment, do you have any question? No? Okay. Now, if you do not have any question, let we go with the slides for this week. How is so? It's not a poll. So, Okay, so in this chapter, we learned about the declaring and using variable and constant performing the arithmetic operation, the advantage of modularizing program, a hierarchy chart, and some feature of the good programming design. So the first, we have to understand the data type. So basically, we already learned that we have in this class normally you have some of the data type, right? The two major category of the data type. The first one is numerics. Numerics, everything about the number here, right? It can be the integer number or it can be the float number here. And the string is anything not in the mark here. So basically, if the format, if data type is in numeric format here, you can do everything with the mark operation. Right? You can add them together, you can subtracting, you can multiplying and division here, right? But for the string here, you cannot use it with the math, right? And also when you understand the data type, it might describe what value of the data type can be held with the item. Right? So basically when you work the program, right, you have to declare for the variable, right? And it depends on data type. So for each of the different data types, they will consume a little bit of different in the memory. You can think about this one here. When you define, this one. When you declare the integer number, right? You have integer number. So in the integer number, it might occupy for the 2 bytes in the memory. But if you declare it in the float number, right? It might store it in the 4 bytes here in the memory. So it depends on the data type. And for the string also, it's different here. So the first thing is the data type describe what value we can be held with the item and how item is stored in the memory. It depends on data type. Each of data types they are stored in the different type in the memory here. And also from the data type, it will tell you what operation you can perform on the item. Right? So think about it, you declare that it's something with a number, numeric format. You can do everything with the math operation here, but in string, if you declare something in string, you cannot do it with the math operation. Okay, so the second one is that about the constant. The constant is that something never ever change during the program. It never ever change during the program. So think about this one here. Think about this one. You want to write a program to figure out what is a state tax, right? So in order to figure out what is a state tax, you need something about the gross income, right? So think about this one here. You can think about state tax here. You can think about this tax here. In order to figure out the tax, you need something about the gross income, right? And you come with the state tax here. I think about this one here. 0.6, it is state tax for this one here. Right, so we can think about this one. 0.6 here, it is constant because the state tax here is always stay 0.6, sorry, 0.06%. Right? It always stay the same during the program. That's why it's a constant. Constant is something it never ever change here. It never ever change. Okay, so we have the two type constant. Constant contains the number of read. Think about this one here, 0.06. Also, you think about this one, number it never ever change. That is constant definition, right? Also, we also have the string constant also. String constant that think about you set the hello here. You set the hello here at the beginning of the program. So it always stay at every program, it's always print out the hello here. And it is constant string, right? So basically just remember constant is something that never ever change during for the whole program here. Now, about variable also, right? I mentioned about the variable. So variable name, variable name, memory location. Right? So it depends on the program. So whenever you have the variable here, think about you have in the program you want to figure out what is a type, right? You want to figure out what's the text here. Text. So in order to figure out the type, you need something about the gross income here. Right? So see the type and the gross here, they are variable. So what happened with this one? They are name memory location. So when you declare the gross variable here, actually it reserves one slot in the memory. And the name of the slot here is the gross. It's the name of the slot here is the gross. Also, you need the program will reserve one slot in the memory with the name the tag here. That's the thing. That's why it is named memory location here. And one thing very important here, variable, you see, it's a vary here. That means the content can vary or differ over time. That is changeable. It's changeable. So the one time you might have the gross here 1,000, and the next time it might be 2,000 or 3,000 and so on here. It's changeable. It's right here. And remember that every time if you get the new value will override the old value here. So think about that at the beginning you assign this one 1,000 here, but the next time you get 2,000, it will override this value and it have the 2,000 here. So something you have to remember about variable here. The first one, it always reference to the specific memory slot in the memory here. And the second one, it is changeable. It's changeable here. It can vary here. So the declaration is a statement that provide variable. The first one, data type. Because you see, if you work with a number format, you can do everything with the merge operation. But if you do with string format, you cannot do it, right? So from the declaration, the first one, you have to tell what is the type of the variable here. The first one. And the second one is identifier. It is a variable name. You can tell that it's a gross or it's a tag here. And optional, you can have the initial value here. So think about this one. I want to declare the gross here, right? So I have the declaration here. Declare here. I have the num and I have the gross here. So what happened here? The declare here, that it is a statement, right? Declaration statement. And I declare the variable name gross with the format is the numeric format here. So basically also after this step, it reserves one slot in the memory with the name gross here. And this one is optional. Optional here. So during the declaration process here, also you can assign value. We can assign value to the variable name here, right? So think about this one. Instead of the declare the gross in the numeric format, now I can initialize the value. I put it here 1,000. That is optional. You can do it later in the program. It's up to you, right? It's up to you. You can do it later in the program. That's why it's optional. Now, you can think about this one here. On the left, it is a flowchart, and on the right, it is a pseudocode here, right? So basically, you see, for every program, the first step you have to do is a declaration. Right? You have to figure out how many bit of variable you use in the program and what is the type of the variable. I will think about this one. This program here is the purpose of this program is to double a number with, right? So for this one, you see, you need the input is a number, right? And output here is my answer here. So input here is my number, and the output here is my answer. And both of them in data type, it is numeric data type here. Right? So that for that reason here, you see, they put num here. Num here, that means numeric data type. Right? And this is variable name. That is variable name, and that is variable name. So what happened here? After the declaration, the program reserves two slots here in the memory. And the first slot here, it is my number. My number here. And the second slot here is my answer here. Right? Sorry. Okay. Now you got the input number, right? You got input my number. So that action here tells the user you have to enter the value for the my number, right? So what happened here? If he enters the number 10 for this one, it stores number 10 in the memory slot of the my number here. Right? And now see this one here in the number format, you can do everything with the merge operation here. Right? So you can multiply, you can division, or you can adding or subtracting, whatever. Right? So for this one here, what happened? This one they call it assignment activity here. So what happened with this one? Actually, see, for every assignment here, you have to do from the right to the left. You have to do from the right to the left here, right? So forget about this one here. this activity here actually it takes the my number here. So it takes my number, it reference to the my number, take out the value of the my number. So now after this step here, I got the number 10 for this one. Where? Here. After this one, I got the number 10. Why I cannot write here anymore? Okay, so after this step here, I can think about this one here, right? After this step, it take out the number 10 from the my number and do with the operation here. It reference the my number and do operation. So we have the my number is 10 times 2, you have 20 here. So when you figure out the number 20, you do the assignment here. You assign the value of the 20 to the variable name my answer here. All right. So now after this step, is the program install the number 20 here into the variable my answer here. It makes sense? Okay. So now it already stores the my number 20 here. The last step is just set into that and print it out to the end user to know what is the name. Sorry, what is the value of it, right? So the process here, output that means it's reference to the my number and takes it out the number and print it out into the screen here. It makes sense? Okay. So here, I just want to highlight again that for every program, the first process it is that you have to declare the variable. Right? So in order to do the declare, you have to declare the variable use here. So in order to declare the variable use, the first step you have to figure out how many variables you will use in the program. Right? For this program, it's very simple. You instantly see that you need 2 variables here. Right? You need the input is my number, and you need the output here is my answer. But for some of the complicated program, you have many variables here. Right? So you have to list down all of the variables used in program, and you have to declare for them. Right? What is the data type? It might be in the number format, or it might be in the string format. Any questions so far, guys? Hello? Any questions?
No questions.
Now, again, you have the 2 major category of the data type, right? The first one is numeric variable. It only holds the digit, right? It only holds the digit here, and it can perform the mathematical operation on it. For string variable, it only holds the text here. And remember, in the text in most of program, the text in most of program is you have to put everything in. You have to put everything inside the quote mark or double quote mark here. That is string. Right? It can hold text, a letter or alphabet, and special character such as punctuation mark here. And it's good for you to do with the type setting here. That means you have to follow with the correct data type variable. Right? So when you do with the string, you just follow string format, and you do with the number format, you just follow with the number format. Okay, now we understanding about the declaration identifier. Identifier is just a variable name. That's a variable name. So if you come back to the example, you come back to our previous example here. Identifier for the previous example, you have the 2 variable name, right? The first one is my number here, my number, and you have the second one is my answer here. That's all. So identifier it is a variable name. And one thing you have to remember that for the good programming here, you always have to choose reasonable and descriptive name for the variable. Think about this one here. If you come back to the previous example, of course you can put this one it's X and this one Y. It's okay. It works, right? X and Y can work, but it's not good program here. Remember that in any program, always try to use a reasonable and descriptive name for variable. So you see, if you have very complicated program, if you look into the variable name, you can figure out what it is, right? But if you look on X and Y here, it's very hard for you to follow up what's going on with the program, right? So I see that in the homework, when you figure out the area of the rectangle, you put X and Y or L and W here, it works also. But it's not good programming way to do it. Only to make the variable name, it make it reasonable and descriptive here, make it meaningful for the values of here. It makes sense? Okay, that is very important here. Do not use X and Y or L1 and W here. Not make sense to the user, to the programmer here. Okay, so you have the programming language have the rule for the creating the identifier. The most language allow the letter and digit. You can use a combination of both of the letter and digit here. And some language allows some hyphen here. And remember here, the keyword you cannot use it. The keyword is something if and else and for and why. That is the keyword, and you cannot use it. And that is very important, right? Variable names are case sensitive. That is the most common mistake when you work with the debugging exercise here. I see that you are not following the rule of the case sensitive here, or you are not allowed. You are not following the rule of the consistent variable name here. And variable name must be one word. That means you cannot have space in the variable, right? So you cannot use variable name. Think about, you cannot use variable name my answer here. You cannot use a space here in the variable name. So remember that the variable name must be one word and must start with the letter and should have some appropriate meaning. That is my suggestion here. Always try to make it with the meaningful variable name. Okay, so that's the way you work with declare the identifier. Right? For this one, you have two variables here, and you declare the my variable. My number is in the number format, and you have the my answer here in the number format. And you have the some convention for variable name. You have a lot of convention, and it's totally up to you. But normally, if you follow one convention, you have to consistent with this one. I think about this one. You can use a camel casing here. Variable name have a hum in the middle, such as hourly wage here. So you see that is uppercase on this one here. You have the uppercase here. You have hum here, and you have the Pascal casing. So the first letter is always in the capital here, and you have many notation here. You can follow whatever it is, but remember that if you choose to work with whatever it is, always to be consistent with this one. Right? Okay, so see you have the snake casing also. You have the mixed case with the underscore. You have cable case. It totally is up to you. Now you have assigning value to variable. That's what I just explained, right? So when you do the assignment here, you have the my answer is set it to my number times 2 here. So what happened here? Assignment operator. Okay. So assignment operator, the first one is have equal sign here. I see that is assignment. Assignment, the first one is have the equal sign, right? The second one is a binary operator, meaning that it requires 2 operands on the 2 sides here, right? And always operate from the right to the left. That's what I explained, right? So basically for this one here, it always have to do from the right here, right? It reference to the For this step here, it refers to the, it locates to the variable name, my number, take it out value from the memory, right? And time it with number 2 here. And after that, you just take the number and you assign it to the variable on the left here, right? Okay, so we also initialize the variable. So after you declare the variable, you can set the initialize value for this one. It totally is up to you. Right? It totally is up to you. Okay, now you have name constant. Name constant, what is it? Remember the constant, something like always stay the same, right? But you see, in the program here, it should be better you put the name for the constant instead of using the direct number here. So see, both of the comment here do the same output, right? Do the same output here. Tax amount equal to the price times sale tax amount, or the tax amount equal to price times 0.06. They do the same, but from the programmer point of view, right? It's very hard for him to figure out what is 0.06. Right, so it should be better that for the in the program, even that is a constant, it always stays the same. It should be better. You put the name for that. You put the name for that. So actually, for this one here, at the beginning of the program, you have to do the assignment here. You have to put the assignment here. Sales, tax, and amount here. And you set it to the value, you assign it to the value 0.06 at the beginning of the program. And that is a step you assign the value for the constant. Right? You assign the constant name here. And so see, after in the program here, you do the tax amount equal to the price times the sales tax amount. It knows that this one is 0.06. Right? So we see this is a very, very simple program, but you see, if you have a very, very long and complicated program, if you have the number here, it's very hard for you to figure out what is it, what's going on, right? So try to, even that is constant, try to put it on it and assign it with a specific value here. Right? So see, it is a name constant is similar to the variable, can be assigned to a value only once because it's constant. Only once, and normally at the beginning of the program. And normally for the constant here, they put everything in the upper case. So we know that is a constant. And if I want to figure out what the sales tax amount, I just come to the beginning of the program and see that is 0.06. Okay. And in the case here, you put the price times 0.06 here. Sometimes they call it the magic number. Magic number, that means I have no idea what it is. If you look on the price times 0.06, if you have the program on this one, you have no idea. That is unnamed constant here. So always try to avoid magic number. Always try to use the unnamed constant here. Always try, even for the constant, if you give it a name and you assign it to the value at the beginning of the program. Any questions so far? Hello?
No questions.
Okay. Okay, so now you're performing the arithmetic operation. So we have the standard arithmetic operation. You have addition, you have the subtraction, you have multiplication and division. Right? Okay, now we have the rule of the precedence or order of operation. So in the case of order of operation, it's the first you have to do everything with the parentheses first. If you have the long operation here, everything within the parentheses, you have to do it first. Now we move to the multiplication and division second, right? And the last one is everything from the addition and subtraction here. So if you look at this one here, I have example here. Right? If you look at this one, I have the example here in on the screen here. What do you think? What is the value of this one? What is the output of this operation? So think about either side x equal to this one. So what is the value of x? What do you think? What is the value of x for this one? You have to follow the order of operation here, and you have to figure out what is the x here. What is it? Now give me the number of x here. Give me the value of x here. And you have to follow the operation. Everything inside the parentheses you have to do is first. Right? Now you move to and after the parentheses you do the exponent, and after the exponent you do with the multiplication and division. Last you do with the subtraction and addition here. And if they are equal, you do everything from the left to the right. If they are the same order, that you do from the left to the right here. So what do you think? What is the value of x here? It's exponent. It's opponent. Sorry, I forgot. So in normally this one is in the Python. I use this in Python here, right? So you have x double here. Oh, not draw here. That means the x exponent to y. Right? So think about you have two double 3 here. That means you have 2 exponent to 3, and you have the 8 here.
Okay, thank you.
So what do you think? What is the value of x for this one? Give me the answer for that.
Is it 32?
Number 2.
Is it 32?
32. Okay, let's see. Let's see what it is.
I got 21.
21. Okay. Anything else? So you have the 32, you have 21. Anything else? Okay. 18, so many. 21, 18, 32. Anything else? Okay, now see what is it here? See what is it? Okay, so see, you have to do everything inside the parentheses first, right? And even that for the parentheses, you have to do the inner before the outer, right? So for this one here, the first step, you have number 4 here. You have number 4 here. So see, in this one here, now I do the parentheses here. I have number 10 minus 2 times 4, right? Minus 2 times 4. So actually, I can replace all here with the number 2 here. Correct or not? Okay. Now see, that's the first step. You have to do the parentheses first, and you have to do the inner parentheses first before you move to the outer one here. All right. So in this one here, you have the 10 minus 8. You have 2 here. That is a parenthesis. Right? Now, the second order of operation is the exponent here. All right. So see, for this one here, you have the 2. You have the 3 raised to the power of 2. You have 9 for this one. All right. You have 9 for this one. So now I rewrite here. I have 15 minus 9 over 3 plus 9 here. Okay. Now, the next step you have to do with the division, right? The next step you have to do with the division here. So for this one, you have the number 3 here. Okay. So I have 15 minus 3 plus 9 here. So now do everything from the left to the right, right? So I have 12 here plus 9. I have 21 here. So 21 is the correct answer for this one. It makes sense? Hello?
Yes, it makes sense.
Oh. So here it is see actually for this one not have the exponent here, but actually have the exponent is a higher. So you can move to the division and multiplication, and after that you have the subtraction and assignment, and later on the last one is the assignment. Why I cannot? Now you know that we have the two group of category of data type, right? The first one is a numeric type, and the second one string here. Now it's a numeric also. You have the integer data type. Integer number is everything in the whole number, right? You can have the 5, 7, or -10. It's always in the whole number here. And dividing an integer by another integer is special case. When you divide two integer number, it results in the integer, and any fractional part of the result is lost. That is when you divide by the two integer number. So basically, if you work with the Python, the work with the Python is the case. Okay, think about this one. So I want to figure out what is a 15 and divide by 4. That when you use the integer division here, right? So for this one, I have 4. I have I have a 3 here, right? But if I put here 15 and divide by 4, I have the 3.75 here. So in the first one, when you figure out when you want to figure out the integer and it get rid of everything in decimal point, that is the first operation here. And in the second one, you just do exactly what is it. Includes the integer number and the fractional part here. Now we have the remaining operator. Remaining operator, that means you just do the division and you take it out. What's the remainder here? What's the remainder here? So think about this one here. If I have the remainder in the Python and most of the programming language, you use a percentage symbol here. You know, in the way you want to figure out remainder. Right? So if I have the 15 here and I do with the number 4 here. So what do you think? What's the remainder of this one? What is the remainder of this one? 15. Sorry. I have 15, and I want to find out what's the remainder of 15 when I divide by 4. What is the remainder here?
3.
Yeah, 3, right? Because when you divide 15 here, when you divide by 4, right? You have the 3, right? You have the 3, and you have 3 remainder of them, right? Because you here 3 times 4, you have the 12. Right? And you have remainder here is number 3 here. So in the case you work with the Python or with the Raptor also, you can do this one here, right? 15 and percentage here. You have this one 0, right? You have no remainder for this one, but you have 15 by 4. You have 3 here, right? And you have 15. So here, what do you have for this one? 1, right? So we see that is the case. If they want to figure out if the number is an even number or odd number. Right? So in order to figure out if it's even number, you just get the remainder when you divide by 2. Right? So if the remainder is 0, you have even number, and if the remainder is 1, you have odd number. Right? Let's see what happens. Okay, so now we understanding about the modularization. The first one is a module. Module is a subunit of a programming problem. It also call a subroutine, procedure, function, or method here. And in order to call a module, it uses a name and invokes the module and calls it to execute here. And modularization is the activity that you break it down the large program into multiple submodules here. And the reason that you want to break it down the large and complicated program into multiple submodules, it's very easy for you to follow up what's going on with the small module here. Right? Also, you can assign it. You can assign one thing for the module 1 and you assign the other thing to another module here. It's very helpful for you to do with the labor optimization here. Okay, so basically, if you work with the modularizing program, normally for every program, you have the main program here. And from the main program, you are able to call. You are able to call for any other module in the program. Right? So in the main program, it includes the module header, right? Module body, and module return statement here. And in the naming of module, it works the same when you naming the variable. And that's why that means that you cannot use the space here, and you have to use the one word here. So here's the thing: when you work with a modularizing program, when the main program wants to use the module, you have to use the action of call. What happens if you call here? You can think about this one here. If you can you see it? You see it, right?
I think that TV over there just turned off. The top one.
I know, but I don't know what happens. I cannot move it here.
There you go. Yeah, I can see that.
Okay. So in the case of the core module name, right? So what happened here? You can think about this one here. You can think of no. Where am I? You can think about this one here. You can think about this one is the main program here. I have main here. Right? So what happened here? In the main program, I can from this. If I standing from main program, I can call any other module of the program here. Right? So what happened here? When I running the program, I want to running the from main program. When I do the function, when I do the action of call module submodule here. So what happened? When you call the submodule, the program will jump it to the submodule, right? It jump it into the submodule and it execute everything from the first statement to the last statement of the submodule. So when you do everything from the first statement to the last statement of the submodule, now you have to jump it back to the main program. You have to jump it back to main program and it move to the next statement of the main program here. So here I just want to highlight again. Whenever you call the module, the action it happened here is that it jump into the module, execute everything from the first statement to the last statement of the submodule. And when you done this last statement of the submodule again, you have to jump it back to the main program and you move to the next statement in the main program. It's very hard for you to figure it out now, but I will have the example later to see what happened here. Okay, so in the case of the module program, you can do it with the flow chart here, right? You see the flow chart here. So this is a very simple example, right? You have the declaration here, you have the string name and number format, the balance that you want to print it out. You want to print it out. What is the name and what is the balance of the employee, right? Also, so we have some information about the manufacturing and what is the address here. So on the left here, it is in flowchart, and on the right you have the pseudocode here, right? So basically for this one here, for this one, you see, you have the two variable here, the name in the string format, right? And the balance here is the number format. And everything here, you see, you got the input and the balance. You got the name and balance from the end user, and everything you have output here, right? This one is address here, this one address, and after that you want to print out what's the customer name and what is the balance of the employee here. So this is very simple program, right? This is very simple program here. So okay, so see, this one is very simple program. You can see that here. Very simple program. Okay, so see, user get the name and get the balance from the end user, right? So now print out the address and print out the name and print out the balance, right? So it's very simple program here. So when I run it, my mouse. Here. Now. Okay, so it's print out here, right? It print out the address. It print out the address and customer name and the balance here. It's very simple program, right? But the thing about this one here, you can break it down. You can break it down in the submodule. You can see for this one here. You can see this program here. You can group all of them together into the submodule. You call the submodule name address. You can call the submodule name address here. So how we do it? In the router here, right? In the router, you can do it very simple by, let me clear it here. So in the router, if you want to break it down with submodule, you have to use the function call here, the call function here, right? Now, I do with the call function, I just drag and drop the call function here, right? And in the call function here, I put the name of address. I click done. Right? So see, when you click done, it asks me, you want to create a new tab? Yes, right? So that is it. That is a submodule. You see, the address here is a submodule. And I want to the address submodule here, print out everything with the address information, right? So with that here, I don't want here I don't want this information in the submodule, in the main module. I cut it, I put it here. I cut it and put it here. Right? So now we see, if you look from the main program, right? If you look from main program, so how we run here? You start, right? You get the name, you get the balance here. So after the balance, you see, it called the submodule address here. So remember, whenever you from the main module, when you call the function, it will jump it to the function. Right? It's jump it to the module here. So actually, it jump it to address here. It do everything from the first statement to the last statement of the submodule. So when you do everything with the last statement of submodule, you come back to the main module. You move to the next statement in the main module. Right? So now you can see it maybe here. If I run step by step here, right? If I run step by step here, now see my name here, David here, right? Think about this one. Now see what happened next when my mom I have the so see what happened here. Now in the main program, it calls to the function name address. Right? So when it calls to the function name address, it jump it to the address. Right? And in jump it address, it do everything from the first statement to the last statement here. print now, print now, print now. So what happened here? When you do everything with the last statement, okay, it jump it back to the main program. See, it jump it back to the main program here, right? See, coming back to the main program, and it moved to the next statement in the program, right? See, now move to the next statement in the program and bring it back here. Okay, actually, this program works exactly the same with the previous one, but if you see for this program here, you break it down into the submodule, right? And this submodule address here do everything with the activity of print now address. That is very simple program. So actually, you do not see any benefit with the modularization here. But if you think about the complicated program, it's very helpful to see what is going on when you break it down in the submodule. Right? So now let me come back to the program from the last time. I don't have anything. Okay, so that is the process of modularizing a program, right? So statement keep out main program and put into module have to be encapsulated. So the process you put everything address into the module address, it is an encapsulation. You do everything inside the another submodule here, right? Main program becomes shorter, right? You can see you hide it from the main program and ship it into the submodule here. And main program becomes shorter and easier to understand. Modular are reusable. That is, I think that is most benefit here. That means when you define the module, right? And you define the module, you can use it anytime later on the program. You can reuse it for multiple times, or even that you can from the another program you can access into the module and reuse it in another program also. And when statement contribute to the same job, we get greater functional cohesion here. So we see for this one here, right? I break it down here. I break it down and I encapsulate everything of the printout address into the function name display address info here. Right? So we do the way it do exactly the same. Right? So when you do everything here, when you call the function, it jump into the function. It do everything from the first statement to the last statement of the function, and you go back to the main module and you move to the next statement of the main module. It makes sense for this one? Hello?
Yes, it makes sense.
Yeah. Now, think about this one. Let me do another one here, right? Let me do another one here. Think about you have push it, right? Number here, right? Now I just want to double the number, right? So my equal to number times 2. And then I print it out. Right? Okay, so now when I run it, press equal, right? I put the number 10 here. Now it print it out. Number 30 here, right? Now see for this one also. I think that this one I can break it down into the three submodules here. The first one is the input, right? We have the here and I input input the process. I got it from the end user, right? So that's why I copy this one, I cut this one, I put it in the input here. Now this one, everything with the calculation, right? So I have another one here. Put this calculation. So this one, everything with the calculation, right? This one here, I cut it and put it here. And the last one, it is output here. Right? Here, output. Okay, so now see, if you look on the main program, right, I break it down into two sub-modules here. Actually, three sub-modules: input, calculation, and output. Of course, this one very simple program. You do not see any benefits with the modularization here. But again, if you work on the complicated program, you see you have a lot of benefits when you work with the modularization here, right? So what happened here? When I remember when you execute program, it overrun from the main program, right? Now it go from the main program. In the main program, the first step, it calls the input module here, right? So when you call the input module, you go to the input here, and there's a number. So after this one, you have to go back to the main module, you move to the next one. You call for the calculation here. So what happened? Calculation, you just print it out the calculation here, right? Go back to the main module. And last thing, the output. Print now, what is output here? That is very simple program. So you see the way it works is that if you run this step by step here, first, now we run this from the main program here, right? We run this step by step here. Start, go to input, jump into the input, start, do everything in the input. Alright, 40 here. Go back again to the main module, move to the next statement. What is the code, the calculation here? What is it? Check it out again, output here. So see, it works exactly the same, right? But for this one, when I look in the main module, I know that I have a three sub-module here: input, calculation, and output. It makes sense? Hello? Any question?
No questions.
So for this one again, I group everything with the address here into the module. Display address for here. Now you have the benefits. What is the benefits of the modularization here? Modularization here. Okay, the first one, program is easier to read. This one you do not see any much benefit, right? But again, later on this slide here, when you work with a complicated program, you see you have a lot of benefits. The first thing is that it's easier to read. So we see if you look into the main module, you see what happened with the main module, right? And if you want to look further down into the every single module, you just go to the every single module here. Easier to design, course, and test program one module at a time. So see if you have the complicated program, you break it down into a multiple module, and you are able to test for every single module here. If you do not break it down into multiple module, when you run, you have error. You have take a lot of time to figure out what's going wrong. But when you break it down into smaller module, you can easily identify what's wrong with this specific module here. And different program module can be can be designed and code by different programmer. That they call the labor division, right? You can break it down into multiple teams and assign each team with the specific module here. Single module may be used more than one place in the program. You can reuse it. So when you only need to code it one time, but anytime you want to use it, you just code it down for multiple times. And the module that perform common programming tasks can be used in more than one program. So see, this one you can use it multiple times in the program, but also it can call it from another program also. So you see, it only needs to code it one time, but you can able to reuse it in your program, or you can even call it from the another program. Now, so declare the variable and constant within the module. And place any statement within the module. You have input, processing, and output statement, right? And variable and constant declaration. You put everything inside the module. And variable and constant declare in the module are usable only within the module. Later on, you learn about what is object-oriented. You see what is going on with this one. And we also have the definition of a global variable. Global variable, that means it's a variable you can use in any module of the program. And again, if you have the local variable, that means it's only used on specific module of this module. So for this one here, right? So for this one, you can think about this one here. You declare everything information here. You declare a variable and constant within the module here. Now, understanding the most common conversion for the mainline logic. That is very important here. That is very important. So I want you to pay attention for this one. And understand the most common conversion for the mainline logic. So mainline logic of almost every procedural computer program follows the general structure, and you have the keyword here. Procedural. So basically, in the programming language, you have two types of programming language. The first one, procedural. The second one is object-oriented. Procedural, that means you break it down into a multiple function. And then you call it and you passing the argument to the programming. But in the object-oriented, you encapsulate everything in the object. And you have the data, you have attribute data, and you have the method inside the object here. So that is, we work with the procedural computer program, right? The first step here, you have the declaration for global variable and constant. Global variable and constant, that means they are variable and constant. You can use in any module of the program. They are global, right? Global, that means you can use any, right? And that's the first step for every program here. The first step you have to declare for global variable and constant here. Now, you have the housekeeping task. Housekeeping task is a step you must perform. You must perform here. You see the name here is must perform, right? You must perform at the beginning of the program. You must perform at the beginning of the program to get ready for the rest of the program. So that is very, very, very important step here. You have to remember that you have to perform it at the beginning of the program in order to get it ready for the rest of the program here. And you have the detail loop here. That is the core of the program. So we can loop, that means you can do it again and again and again and again. Right? For many times you want. Now, the last one is the end of job. That means when you've done everything, when you've done it, right? You just print it out, that you finish it, or any information you want to print it out. Now, you can see it. You can see it in the example here, right? That is a flow chart here, and on the right again is a pseudocode, right? So if you follow the structure here, the first step, you have to declare for global variable and constant here. That's why you declare you have the declaration here. Everything with the global variable and constant. You do first, right? Now the next step here, you have to do the housekeeping. Housekeeping, you must perform it. You must perform it at the beginning of program. And remember here, so housekeeping here you have to do at the beginning of the program, but outside the loop. You have to pay attention to that. It only do outside the loop, before the loop, not inside the loop, right? So if you look on this one here, if you look on the flow chart here, that's the action of the housekeeping. And here's the loop, right? You see, that is the loop here. Housekeeping only do before the loop, outside the loop, right? And when you do the loop, you only have the condition to check, right? If it's correct, you do it again. Correct, do it again. Correct, do it again. And if not correct, you exit it here. And so here is the condition to check. If yes, keep doing it again, keep doing it again, do it again. And last one is end of job. You just pay now, you finish it, complete the job or something, right? So see on the left here, you have the flow chart, and on the right here, you have the pseudocode. The first step, declaration. The second step here, housekeeping before the loop. And in the pseudocode here, whenever you see y and y here, it is a loop. Why does that mean? If it's true, keep doing it. If it's true, keep doing it, right? So whenever you see the y and y here, everything here is a loop. And you see the housekeeping here, outside of the loop and before the loop. Right? And last one, you have end of job. I'll give you the specific example later on so we can see, you can clearly see with think about this one here, right? You want to report, you want to print it out the payroll for every employee, right? So you see, for this one, it should be better to do the loop here. The first one, end of report or not do the second one, end of report or not, do the third one, do the fourth one, and so on here. Right? That is loop here. Now, that is example here. You can see what happened with this program here. Now, this program here, what is it? Okay. This program you got the name, you got the name from the employee. If you got the name from our employee here, and for each employee, you got the gross income, right? You got gross income, and you figure out what the deduct, and after that you figure out what is the net income here. So basically, for this program here, you can see for this program, you can do it for multiple employees in the company, right? You have a multiple employee here. For each of the company, you have something here. The first, for each employee, you need some information here. The first one is name. The first one is the name. The second one is the gross income here. The second one is the gross income, right? The gross income, and you have to figure out. You have to figure out what is the net income. You have to figure out what's the net income. So see, this one is input here. This one is input, right? And this one is output. But in order to find out what is the net income, you need to figure out what the deduction. And the deduction, you have the rate here. And so the net income is the gross you deduct for the deduct here, right? So if you look on this program here, remember the first step in every program is declaration, and we have to declare for every global variable and constant here. I see. If you look on the declaration here, you clearly see here. The first step, declaration. Name here is a global variable. And gross here, global variable. And deduct here, global variable. Net here, global variable. Rate here, what is the rate here? Constant. Constant because every employee, they have deduct rate of the 25%. So see, that's why they put everything in the uppercase here. So when you see everything in uppercase here, it is constant. And for every employee, they have deduction rate, it is a 25% here. Also, for this one here, this is a constant here. This one constant. Report heading, column heading, they are constant. And the net here is global. Now, see, when you then everything will be declaration. The next step, it is the housekeeping. Housekeeping, you must have before the loop and out of the loop, outside the loop, right? So why do you need the housekeeping here? So what happened here? You see, if you execute program, right, you do everything with declaration, you call the housekeeping here. So when you call housekeeping, actually you have to jump into the housekeeping. You do everything from the first statement to the last statement here, right? So with the housekeeping here, you actually use the print now. I print out report heading and print out the column heading. It doesn't matter much with the program. The more important is the housekeeping here. You have to input the name. You have to input the name of the first employee. You must get the name of the first employee. So why? Why do you need to get the name of the first employee here? Here's the thing. You see, when you do the loop, right? When you do the loop, you always have step of the check the condition, if it's correct or not. Right? You check the condition. So for this one here, you check the condition if the name equal to x here. You exit the loop. Because I want to do it again for many employees here. And if I want to stop it, I just put the name is x here. I stop it. Right? So see, For every loop, you need the condition to check. And the condition check here is that when you check here, if name, you check the name, is the name here equal to x here, I exit it. Exit the input name for the first employee outside the loop. If you do not have this step here, or what? If you do not have the step here, you have nothing to check with the condition, and you got the syntax error. Right? That is a very important step in the housekeeping. Housekeeping is very important step you have to do before the loop, outside the loop, and get ready for the body of the loop. Without it, you cannot do it. Right? Now see, you can clearly see it with the wrapper program here. Where am I again? Yeah, you can see it here. Okay, so you can see this in my Raptor program here. Everything here is declaration. Everything here is a declaration. So I have constant rate here, 35%. I have the quit name. That means I want to quit the loop, right? And is the header reporting header here, and is the Raptor you do not have to declare the gross or net income before you use it. That's why I do not declare here, right? But it's very important. Housekeeping. Housekeeping, that you see when you look onto housekeeping here, what happened here? Housekeeping, what happened here? Very important. I get the name of the first employee, and I got the name of the first employee here. So when you do everything with housekeeping, I come back to this one. I go to the loop, and you see the condition of the loop here. If name equal to the quit is that mean I here. If it equal, I quit it. I exit it here. If not, keep doing it here. So now let me run it here. Let me run it how we see. Let me run it here. Okay, now see, I enter name, right? Now think about the first employee is name. Right? Now you see, when you do with the loop here, when you look, right? If I enter the name is David, it's not equal to quit. What's the quit? Quit is X, right? So it's not equal to quit. That means I keep doing with the loop here. I keep doing the loop. So what is it? When I keep doing the loop, I call the module detail loop. What's the detail loop? Detail loop, I get the gross of the employee. Right? I figure out what's the deduct here, and I figure out what's the net here, right? And I now that's important here. When you get the gross of the first employee, you figure out the deduct, and you figure out the net here. If you want to move to the next one, if you want to move to the next employee here, you need to get input for the next employee. Right? In it to get the information for the next employee here, and the information you need to get it from the another employee, it is the name here, because the condition to execute the loop is only to check the name. Right? You only to check the name. So see what happened here. I put this one, the 5,000 here, right? 5,000 here. You see, if I will have the 5,000, right? So after this step here, I will figure out the net of the first employee here, the 3,750 here. But I still need to get the information for the next employee here in order to do the loop. Otherwise, I cannot run the loop here, right? Otherwise it means an indefinite loop. And show you how to work with this one later. Now see, you see, you have the action here, enter the name. What name here? Actually, is the name of the next employee. Right? Not this employee, the next employee. So if you want to exit it, you just enter X here. Tell you very clearly, right? So now I want to do another one here. I put it to the one item here, right? See what happened with the item here. What happened with item? Again, you see, look at this one. If I enter the item, right? I come back to the row, check name item is not equal to X, right? That's why I do one more time with the loop here. Again, that is gross income of the second employee here. Right? And now if I want to quit the program, I so see, it check right? I finish it here. Okay. Now I know it's very hard for you to follow up with the program here, but I want to explain it again one more time here. Housekeeping here. Again, it's very important step. Do before the loop, outside the loop. And for this program here, the more important thing is that you need to get the name. Right? You need to get the name in order to check the condition of the loop. If you don't have this one, you got the syntax error here. Now, let me do it here. If I delete this one, I run program here. See, you got the syntax error here, right? Because here, I don't know what's the name. You do not have the action to get the name first, right? That's why when you go to the loop, you check the condition here. What's the name? I have no idea. Right? So what that see that you see the importance of the housekeeping here. Housekeeping do outside the loop, before the loop, and that is the action to get ready for the loop to run. Without that action, the loop cannot be run here, right? Cannot be executed here. Right? So that for that reason here, you see the importance of the housekeeping. You must get the name. And the name here, it is the name of the first employee. You only need to do it one time a week in the housekeeping, right? That is the first employee. Right? And later on here, in the detail loop here, you figure out what is gross, you figure out what's the deduct, what is the net, what income here. Now later on, if you want to move on the loop, you need to get the name of the next employee here. Make sense? Any question? Okay, now see what happened here. What happened if I delete this one? What do you think? What happened if I delete this one? I do not get the name of the next employee. What do you think? What happened if I delete this one? Yes.
It'll just do the same name.
Yeah. Do it the same name over and over again, the same name, and which will be the endless loop here. And because it always say at the David, right? And never ever equal to the X here. That's why it is endless loop. Do it forever. Right? You see for this one here. If I delete this one, if I delete this one. Now see what happened here. I delete it. You see, it again enters the gross. But what happened here? The name here already. The name here already. Actually, you do it for multiple times for David only, and it never ever exits the loop because the condition here to check the loop here. The condition to check the loop name equal to the quit. But if the name stay at the David, it never ever equal to X. That's why it do it again forever. Right? So that is something very important here in the loop in this program here. The first thing, the housekeeping, it is a step you get the input from the initial before the loop, right? And inside the loop, you also have the action to get the name of the next employee. Otherwise, you need this endless loop. Right? It makes sense. Any question? Hello?
No questions.
Okay. and you can see it in the Python also. Okay, so we see in the Python, do the same. I have the housekeeping here. The most important step is that I have to get the name. That is the name of the first employee. Right? So we see, I check here. If I do not have action to get the name here, right? This one we got the syntax error here because I do not name it what it is. Right? If I do have this action here. Okay, see, when we done everything with figure out and print it out the net income, right? You need the action here to get the name of the next employee. Otherwise, it will be the end. And let's look here, right? So I think you should take a short break for 10 minutes and come back later. So in the meantime, and one more thing I just want to mention here. If you look on the right here, it is pseudocode. And I expect you have to understand the pseudocode here because you see it in the debugging exercise. You see it in the debugging exercise. So when you understand the logic, it's very helpful, it's very useful for you to do with the debugging exercise. Okay, so we go on. So basically, if you look on the right here, right, it is pseudocode. You do everything here. It is a declaration. Right? Housekeeping before the loop. And what happened with housekeeping? So when you execute program, housekeeping will jump into the housekeeping here. Do everything from the first statement to the last statement here. And the most important thing is the housekeeping here. Input the name. Right? You only got after only after you got the name, you are able to check the name equal to quit or not. If you do not get the name in the housekeeping, you have no way to check if the name equal to the quit or not here. And you got the syntax error, right? That's why you see housekeeping before the loop, outside the loop, and it's action to get that name with the body of the loop. Right? So now housekeeping, everything. Put name here, it's only for the first employee only. Right? Remember that is only for the first employee. Now you go with housekeeping, you check that it's not equal to the quit what is here, right? You need to do the details loop. What's the details loop here? Details loop, you do everything with the details loop, right? You get the cross, you figure out the deduct, sorry. You figure out the deduct, right? Figure out the net, and print it out, name, gross, deduct, and net. See, that also very important step here. That is also very important step here. Why I cannot draw it anymore? Yeah, you need the action to get the name for the next employee in order to do with the new loop here, right? Otherwise, it stays the same. And last one, the end of job is the print out and apply it. Very simple here. So I expect that when you look on the pseudocode here, you have to understand the logic of this one, right? And very helpful if you understand the logic here, you convert it into your the understanding into the debugging exercise. You know what goes wrong with the debugging exercise. Okay, so normally for the modularization, right? You can do it with the flowchart. You can do it with the pseudocode. But the action, if you want to break it down in the submodule, the easier way is a hierarchy chart. The hierarchy chart is the one. It shows over a picture of how modules are related together. You see that even in the complicated program, right? You can break it down into multiple modules. And from module, you can break it down in the submodule. And from the submodule, you break it down in another sub. Right? So by looking on hierarchy chart here, you see what is the connection, what's the relation between them. Right? Tell you which module exists in the program, which module calls as a one here, and specific module may be called from the several locations within the program. Right? So here, you can think about this one. In this program, right? Very simple. You have main program, you break it down into housekeeping, detail loop, and end of job here. Right? And you even have the more complicated here. In the housekeeping, you can break it down into the get order, or in the detail loop, you can have the process order and the get order. And in the process order, you can furthermore you break it down. Right? So if you look at hierarchy chart here, you see what is the connection, what is the relation between the module. Right? And you see when you call to the detail loop, what action you have to do? You have to do the procedure order and process order. What you have to do? You have to check the inventory, you have to check credits, and so on. Here. You see that's the relation and how each module call another module here. Okay, so we have the some feature of good programming design. Use the program comments. It's very good habit of programming that try to use the program comments. Right? So basically, you have the two type comments. You have the header comments and you have the inline comment. Right? Identifier should be chosen carefully. Only choose the name of variable, meaningful name. Right? Always try to do something to tell you what is going on with the variable here. Do not use X, Y, or L, or W here. Instead of use width or length, should be better. Try to design clear statement with your program and module as clear statement. Write the clear prompt here. Prompt also very important, right? Very important here. And use eco input. Continue to maintain good program habits as you develop your program skill. Okay, now here one thing here. One thing I want to show you something here. Right, clear prompt and eco input here. So eco input that means you can go back to use the value of the variable you used it before. Now see how it works with eco input here. Think about this one here. Think about program here, right? Go back to the program. Right? See for this one here, right? Program print out the answer is a double number, right? So now, what is the eco input here? So instead of using here, I run it here, right? I run number 10. I have output here 20. have an output here something. But done it again. And this one. This one, right? Now, if I want to use the equal input, I can tell here. I can tell in this one here. My answer is 20, and it is a double number 10 here. Right? Or the next time if I enter the number 20, I have my answer is 40, and it is a double of 20 here. So when I use the 10 and 20 here again, it is the equal input. Now let me correct it here. Let me correct it here in the program, right? So I can change this one here. My answer is here. It is a double. Okay, so see, it's the output, right? I call again the number from the input. That's why they call it equal here. Equal here, right? See what happened here. What happened if I run the program here, right? I enter the number 15 here, right? So see, my answer is 30, and it is a double of 15 here. Right? So see, when I call back again 15, actually I take it down from the number value here. That is the equal here. Make sense? So you see, it makes more sense for the end user, right? You can think about this one. Or in the program to figure out the area of rectangle, right? So in the inputs, you can tell that the area of the rectangle with the width is and the length is something, right? Make more sense. You take it out the value of width, you take it out the value of length, and you print it out the area. SOC. All right, clear prompt and equal input here. Program comment. That's the one I mentioned in the last slide. You can use a header comment, and you can use a inline comment. One thing is that if you work with a router, I'm not required to do the inline comment. It's very confusing, right? Very hard to follow. So in the router, you just need to do the header comment only. And is that you have the format for the header command, right? You have the name, you have version, you have the list down variable you use in the router. Okay, so that normally in the pseudocode, whenever you use the double slash here, that is a comment. Right? And remember that the comment is only useful to the programmer only. From the computer point of view, from the when you execute it, you ignore everything in the command. Right? It doesn't matter. It's a computer, but it's very helpful for the programmer to follow up with what's going on with the program. Okay, so see that is an example of the command here, right? You see what the rate is expected to increase on the January 30th. Tell we have some information in this one. Assume that all employees make the same standard hourly rate. Yeah, and choosing the identifier or the variable name. Identifier is variable name, right? General guide. Give a variable or constant a name. That is now because it represents a thing, right? Give a module an identifier. That's a verb. So normally for the variable and constant, you give the name, but for the module, it's a verb because the verb is action, right? So think about calculate, get input, print out output. That is. Use a pronounceable name, avoid the digit in the name. Choosing any the guy. Use your system, your language. So you have the sum of the standard, right? When you follow the standard, be consistent with your standard. Avoid confusing libraries. Okay, one more thing is very important here. you try to use a temporary variable to clarify the long statement. Think about this one here. Why? I think. Okay. You can use a temporary variable to clarify the long statement. Why? I think I have something here. Okay, please. So think about this one here, right? So on the top here, you have the sale commission. You are able to figure out the sale commission. It is original price, right? Minus for original price, time discount rate, and time with the commission rate. It works also, right? But it's very hard for someone to follow with the program. So it should be better you can use temporary variable here, right? So instead of that, you set the temporary here, discount price. What is the discount price? Discount price is original price, time discount rate. Right? So you can think about this one. You can break it down. You can break it down into the temporary variable. The first one here, you assign the whole thing here with the discount right here. Right? The discount right here. Now you have the sale price. Sale price is original price minus discount price. So everything here, it is a sale price. Right? And last one, sale commission here. It is sale price times the commission rate. So see, this one here from the computer point of view, it do exactly the same as this one. It do exactly the same. But if you are a programmer, if you want to follow up with the coding, right, it should be better if you break it down in the smaller calculation here and you follow up what's going on. Prompt, right? Always make the prompt more meaningful here. Always make the prompt more meaningful. And the prompt and equal inputs. I just gave you the example here, right? And see, if you do not have the prompt, right? You see, you have the input name and balance here, input name and balance. Right? But you see, in the case if you use the prompt, it's very helpful for the end user, right? You see what's going on here. Tell user that please enter customer name. So he have idea what he has to do here, right? If you do not use the prompt, it's very hard for him to figure out what he has to do here. Right? So you see this program here and this program again from the computer point of view, we do the same. Right? You do the same, but if you think about you as the end user, you expect something more meaningful to you, right? So try to always use the prompt meaningful here. So enter customer name and please enter the balance due here. It makes more sense, make more meaningful for the end user. Okay. And you see that is the mistake here, right? You see in this one here, everything remember in the prompt, right? Everything inside in the prompt here, everything inside the double quote mark here. They are text. We now exactly text, right? But if you want to take it out, the name or variable value, you have to follow up with the variable name. And in the wrapper, you put the plus sign here. Maintaining the good programming habits. Every program write better. Of course, you know the software development life cycle, right? You have to understand problem. You have to do analysis. You have to do the planning, right? You do the coding, testing, integration, and maintenance. Yeah, right. So for every program, it should be better you plan before you code. Of course, for all of the programs so far, it's very simple, right? You can figure out what is it. But if you think about if you have the complicated program, it's always better you have to plan it before you code. You have to figure out what's the variable. You have to figure out how many modules you have to break it down. Right? You have to plan it before you do it and maintain the habit of first drawing here. You have to draw in your flowchart or write the pseudo code. That check, what is that check? That check, that means when you do the planning, you have to figure out all of the starting scenario. Right? What happens if you enter salary is a negative number? Right? What happens if it's not a number format here? All of the testing scenario, you have to do it. Right? think carefully about the variable and module name. You will design the program statement to be easy to read and use. Okay, so basically that's all for the lecture. Okay, now you go with the sum of the Python overview here, because in this class you also have some Python assignment, right? Again, is a Python variable the same, right? Variable is a name that represents a storage location. It points to the specific memory slot, right? And you use assignment statement to create a variable and make it reference to the place right there. And remember, variable are reusable, right? Changeable. You can reuse it. So the first time you put the number 10, and the time you put the 20 or 30 and so on. Or this one I think I reserve it for and give it to the next on the Thursday. Sorry, yeah, on Thursday. I see. Let me see. And then if you sample the zero code. Exactly, very simple, right? This is quite the same with the programming. We double the number here to value the sum different. So very simple. I don't know why I wrote this pseudocode here. Okay, so maybe the website app. Yeah, sometimes it's happening with the second. Go here. So here's my suggestion. So here's my suggestion. So before you go on Thursday class, try to work out with the debugging exercise. Try to work it out with the after assignment and the Python program here. And on Thursday, if you have any problem, you can raise to me. I can help you with the assignment on Thursday. Okay. Any questions? Okay, let me check the attendance here. Zachary Baker, are you here?
Yeah.
Okay. So here. Cameron, are you here? Hello? Yeah. Rickman, are you here?
Here.
Emiliano, are you here?
Here.
Riley, are you here? Hayden, are you here?
Yeah, I'm here.
Zasman,
Here.
Luke,
Yeah.
Diego,
Here.
Nicosin, sorry, sorry, I don't. Nick. Are you here? Jack, are you here?
Yeah, I'm here.
Jose? Martin, are you here? Shalon, are you here? Nathan, are you here? Nathan? Aiden?
Here.
So I see you guys on Thursday. Remember that you try to work on with the pseudocode, right? Debugging exercise. Try to work with Raptor. Try to work with Python assignment. So for anything come up, then come back to me on Thursday. Okay, see you guys. Bye bye.
Thank you. Have a good day.
Bye.